The ear and hearing loss. How are you in danger? So today I'm going to be discussing the technical and delicate mechanisms of our ears that grant us the ability to hear, and how hearing loss is becoming a rising issue in today's society as a result of our exposure to loud sounds such as music or construction work. Now, in order to understand how such loud noises can cause irreversible ear damage, we must first understand how we hear. In short, hearing is the ability to perceive sounds by detecting vibrations and changes in the pressure of the surrounding medium through time. First, sound waves enter through the outer ear, making their way through the narrow passageway called the ear canal, which leads to the eardrum. These sound waves then cause vibrations to three tiny bones in the middle ear, the malleus, the incus, and the stapes. The bones in the middle ear couple the sound vibrations from the air to fluid vibrations in the cochlea of the inner ear, which is shaped like a snail and filled with fluid. An elastic wall runs from the beginning to the end of the cochlea, splitting it into an upper and lower part. This partition is called a basilar membrane, also known as the tympanic membrane, on which key hearing structures sit. Once the vibrations cause the fluid inside the cochlea to ripple, a travelling wave forms along the basilar membrane. Hair cells, also known as sensory cells, sitting on top of this basilar membrane, then ride the wave. As the hair cells move up and down, microscopic-like hair projections, known as the stereocilia, that perch on top of the hair cells, bump against an overlying structure and bend. Now, a more in-depth look. So, bending causes pore-like channels, which are at the tips of the stereocilia, to open up. When that happens, chemicals rush into the cell, creating an electrical signal. The auditory nerve then carries this electrical signal to the brain, which then translates it into a sound that we can recognize and understand. What exactly is noise-induced hearing loss, also known as NIHL? Noise-induced hearing loss occurs as a result of loud and long-lasting noises which can cause damage to these sensitive structures in the inner ear. It can occur immediately, or it can happen over a long period of time and can be permanent or temporary. Loud noise in particular is very harmful to the inner ear, the cochlea. Listening to loud noise for a long time or in a specific instance can cause these hair cells to overwork and also can cause them to die. The hearing loss progresses as long as the exposure continues. Harmful effects might even continue after the noise has stopped. Now, damage to the inner ear or auditory neural system is generally permanent. The average person has approximately 15 to 18,000 hair cells within the cochlea, although in order for hearing loss to be detected by hearing examinations, at least 40% of these must be destroyed, and by this time they are beyond repair. Now, what causes NIHL in terms of decibels and sound? So, in terms of decibels, sounds less than 75 decibels are considered safe and aren't likely to cause any hearing loss, even with prolonged exposure. Although, as sound increases beyond 85 decibels, your ears are at risk of being damaged. Just to give some numbers as reference, normal conversation occurs at 60 decibels, and an MP3 player playing at maximum volume sits at roughly 110 decibels. So the next time you're playing songs at a high volume through your earphones or your car speakers, just remember, although you think your hearing is good now, you may be slowly damaging it beyond repair. Similarly, higher pitched frequencies tend to occur at higher decibels, whereas lower pitched tend to occur at lower decibels. And this is just a chart indicating different decibels of different noise stimulations, such as the top being jackhammer at 140 decibels, which is sure to cause ear damage, and that's why earmuffs are a necessity on a construction site. Can noise-induced hearing loss be treated? Now, although there are no conclusive treatments for public use, there have been some successful trials to renew damaged hair cells. But the most effective method of treatment is, of course, prevention. If one understands the hazards of noise, whether that be on a construction site or in a car listening to music, you can protect your hearing for life. Firstly, it's imperative to know that anything above 85 decibels will damage your ear. If noises cause an uncomfortable vibrating sense in your ear, then you're effectively damaging your hearing. If you're unable to remove yourself from the loud environment, then wear earmuffs or protective equipment to reduce noise levels to the ear, as you can see in this picture. So what does the future look like in terms of repairing damaged hair cells? So a new study led by scientists at Rutgers University, New Brunswick, has demonstrated an exciting new gene therapy treatment that stimulates inner ear stem cells into becoming auditory neurons. The technique could potentially reverse hearing loss in many people, but the researchers urge caution as the stimulation of these stem cells could also have major side effects, such as increased cancer risk. They found that although they can make neurons, there are dangerous side effects that come with it, such as proliferation of stem cells. Ultimately, this study offers scientists working with stem cell therapies a fair warning into how treatment can be a double-edged sword, and more research is necessary and more trials must be done in order for an effective treatment yet to be discovered. Thank you for listening, and I hope you have learned a lot from this video.